I welcome all the students. We have already started learning the unit number 4, okay? And we have already covered the point viewing transformation and windowing transformation. Okay, so today we are going to discuss the point clipping operation, or we are considering the point clipping and the basics of line clipping. Okay, so today's topic of discussion is what is meant by the clipping and clipping operation. Then we are going to consider the point clipping and clipping operation, then point clipping and line clipping. Okay, so after covering this, okay, we will continue with the remaining part in the consecutive session. Okay, so let us start understanding what is mean by the clipping. Okay, I just focus today's part, today's session. We are going to cover this points. Clipping operation. Okay, any procedure that identifies those portion of a picture that are either inside or outside. So I'm having a procedure which identifies the portion of the picture, whether it is inside or whether it is outside of a specified region of the space, is referred as, this procedure is referred as the clipping algorithm, or simply we can call this as a clipping. Okay, so in simple word we can say the clipping identifies given a specified region. Okay, so given a specified clipping window, the clipping algorithm or simply clipping identifies whether the given portion of the picture is either inside of the clipping window or whether it is outside the clipping window. Okay, so that is what we are going to learn. Okay, the region against which an object is to be clipped. Okay, the region that I'm defining against which I'm going to clip the object is known as my clipping window. Okay, so I call it is my clipping window or it is my clip window. So the region against which an object is to be clipped is given as clipping window. So I must define the clipping window. So considering this clipping window, the clipping algorithm or just clipping is going to decide whether which part is inside the clipping window and which part is outside the clipping window. Okay, so this is what we are calling it as the meaning of the clipping. Okay, now let us understand the applications of the clipping. Okay, so where this clipping is useful, so the clipping is having the n number of applications. There are so many applications where the clipping is useful or it is used. I'm just listing some of them. First one, the first application is extracting the part of defined scene for viewing. So I want to extract only the part of the scene, okay, for the purpose of enlargement or purpose of the viewing. So I use clipping. Identifying, second application, identifying the viewing surface in the three-dimensional views. In the three-dimensional views, I just want to identify some of the surfaces, okay, in the three-dimensional view. So in that case also the clipping is used. Then we can use the clipping in anti-aliasing line segment or object boundaries. Okay, so we have learned this anti-aliasing and how the clipping is useful. Okay, then the fourth application is creating objects using solid modeling procedures. So in creating the object which is having the solid modeling procedures are also we are using the clipping model or we are using the clipping inside it. The next application is displaying a multi-window environment. Okay, if I want to display multi-window environment, then also I will take the help of the clipping procedure. Okay, and sixth application, I told there are n number of applications are there where the clipping is useful. Okay, in normal way, if you have seen that whenever you take a picture, okay, or the photograph from your mobile, and generally before posting it, that photograph anywhere, what you go for is generally you go for the beautify option. In the beautify option, you go for the crop the image. Okay, what is mean by crop the image? You are selecting the clip window, okay, and you want to select only the part which is inside that window, and generally that window is rectangular. Okay, So you use that rectangular window, and whatever part you select in that rectangular window, that part is only retained, okay, and the outside part is removed from the image, and that is what we call it as the clipping, okay, and that is used everywhere. Okay, so six application I'm just listing. Drawing the painting operation that allows the part of a picture to be selected. So I'm going to select the part of the picture to be selected for the purpose of copying, moving, erasing, or duplicating, etc. Okay, so all these are, there is a wide range of application of the clipping. Okay, I have listed some of them, and I hope all of you cleared with the basic definition of what is mean by the clipping or how the clipping is used. Okay, so we are continuing further our discussion of the clipping. Okay, so I just moving to the next slide to continue the discussion. Okay, now as we have seen, there are so many applications of the clipping. We can also mention that for viewing transformation, I think just now we have covered already in session the viewing transformation. So for viewing transformation, we want to display only those picture part that are within the window area. Okay, and this window is nothing but we can also consider it as a clipping window, or we can also consider it as a clip window. Okay, clipping window. Now in the same case, if once I define the window, then what is going to happen, everything outside the window is discarded. Okay, so once my window is clear, my clipping window is mentioned, then everything which falls outside this window is definitely discarded. Okay, it is discarded by the clipping algorithm. Okay, now clipping algorithms, okay, so just moving to this point, clipping algorithms can be applied in word coordinates so that only the contents of the window interior are mapped to the device coordinate. Okay, so here this clipping algorithm point indicate that whatever, though I have defined it in the word coordinate system, okay, only the contents which are inside the window are mapped to my device or screen coordinate system. Okay, so there is no need to consider the other part, so mapping will be more easy. Okay, and I'm going to map only the interior part of the window, or the part which is inside the window. Okay, so just moving, continue our discussion with this. Now then viewport clipping. Okay, so the viewport clipping means now I'm considering about the device coordinate system or screen coordinate system. Viewport clipping can reduce calculations. So this clipping will help us to reduce the calculation by allowing concatenation of viewing and geometric transformation matrices. So this is one of the, we can say, advantage of the clipping. If the clipping is used in the viewport, then it is going to reduces the calculation. Okay, so all these are the different application or the description where we can use the clipping. So understanding the clipping algorithm is important for us. Okay, so let us move to the next point. We are going to consider the algorithms for clipping of following. So what we are going to learn, we have learned just now, we come to know that the clipping is very important, and we have come to know that what is meant by the clipping. Okay, now again to make this point clear. Okay, so in simple word, what we can say, what is meant by the clipping, or what is the clipping algorithm does. So clipping algorithm is going to discard the part of the window which are outside and retain the part which is inside. Okay, see what I'm just want to consider in this particular case is, suppose I came to know that only this is important for me. Getting me? As the clipping window is nothing but it is a rectangle. Getting me? So clipping window is rectangle. Assume that whatever I am showing it here, getting me? Whatever I am showing here, suppose this is my clipping window. Okay, assume this is my clipping window. Getting me? This is my clipping window. What will happen? What the clipping algorithm will do? Clipping algorithm will maintain which is inside. Means whatever is written inside this rectangle or the clipping window is maintained, which is outside will be removed. Because I found that all these points may not be important, only this is important. So I focus my clipping window is used to focus on the part of the picture of your interest. Okay, so you are not interested in other part, you are interested only in this particular part of the picture, and that is you are deserving with this clipping window. Okay, I hope all of you cleared with the what exactly the clipping procedure does. Okay, now we are going to learn what we are going to learn in the next slide says we are going to consider the algorithm for the clipping. So which are the algorithms for the clipping are applied? So first we are considering the point, what is mean by the point clipping. We are going to consider what is point clipping. Then we are going to consider what is line clipping, how to clip the line, and then we are going to consider how to clip the polygon. Okay, so under clipping we are going to learn the all the details related to point clipping, related to line clipping, and related to the polygon clipping algorithm. Okay, so this is what our point of discussion. So we are going to consider this in detail. Okay, so instead of wasting time, let us move to the understanding of what is mean by the point clipping first. Okay, so I'm just moving to the next slide to understand this point. Okay, so what we are discussing, so we are discussing the point clipping operation. Okay, now assume that a clip window is rectangle in standard position. I think we have mentioned this point earlier. Generally or standard position, the the clip window is always considered as a rectangle. Okay, now suppose we are having the point P. So P is equal to x comma y. So we are having the point P is equal to x comma y for display. Okay, so now we have to decide, see what is our clipping point clipping operation does. Our point clipping operation will identify or it will detect whether this point P, which is having the value x and y coordinate value, whether I have to display it or whether I not have to display it. Okay, when the point is displayed, if the point falls inside the clip window, okay, or it is interior to the clip window, then it is displayed. If it is not inside the clipping window, obviously it is not displayed on the screen. Okay, now what we have to do is, now we save a point P comma, save means display. We are going to save or display the point P is equal to x comma y for display if the following inequalities are satisfied. So definitely we required some equation or we required some formula or condition to satisfy, to decide whether the point is to be saved or displayed or whether the point is discarded or whether the point is inside the clipping window or whether the point is outside the clipping window. And for that we are just considering the following inequalities should be satisfied. Okay, what is the condition should be satisfied? The value of x value of the point P should be less than or equal to xw minimum. Getting me? It should be less than xw minimum, and it should be greater, or we can say it is the value is in between. Rather, I say the value of x should be in between xw minimum and xw maximum. Xw minimum and xw maximum. So x value. And what about y value? So the value of y, point P, y value should be in between yw minimum and yw maximum. It should be in between yw minimum and yw maximum. Okay, so generally how we have defined, okay, so I'm just showing this as, suppose this is my complete screen. See what I'm going to see, I just consider that this is my complete screen, and inside my screen I'm just changing the color here for understanding. Suppose this is my clipping window. Getting me? This is what? This is my screen and this is my clipping window. Okay, and now I'm having a point. Okay, suppose this is my point P. Okay, consider this is the point P. Okay, so this point P, okay, now we are considering it is having the value x and y value. This is the x and y value of the point. Okay, now how I can define what is xw minimum? See, this is my x value, so this will be my xw. W stands for window. This is my minimum value. Okay, so this is my xw minimum, and obviously this is my xw maximum. Getting me? So I am having this value xw minimum and xw maximum. Similarly, what is my yw minimum? Obviously, this is my yw minimum and this is my yw maximum. Okay, so this is yw minimum, this is my yw maximum value because this is my y-axis. Okay, this is my y-axis, this is my x-axis. Okay, now if the point P is having the value x comma y, so what is my x value of the point P? It should be in between xw minimum and xw maximum. It should fall in this range. Getting me? So x value should fall in the range xw minimum and xw maximum. And what is the value of y? Well, y value should fall in between the range yw minimum and yw maximum. Okay, so if that is the case, it indicates that my p is saved or the p is inside and we have to display the point p. Okay, if my p is outside, I'm just taking this as an example. Suppose this is my another point p. Okay, so I'm just showing it here. Suppose this is my p point, this is my pixel p, then what will happen? This p is having the x value and this is having the y value. Okay, but what is going to happen? The x value for this is inside xw minimum and xw maximum, but what about y value? The y value is outside. Y value is outside the yw maximum. This is my yw maximum, but point is here, so it is outside. Okay, so that's why I have written this point. Just look at the another point is where the edges of the clip window, getting me, where the edges of the clip window are xw minimum, xw maximum, yw minimum and yw maximum can be, okay, just now we have seen with this example or the diagram, can be either the word coordinate window boundaries or viewport boundaries. Okay, so I'm considering my window is having the xw minimum. Okay, so I'm just using the different color, one more color here to indicate that this is my xw minimum. Okay, this is also called as my left window. Okay, left window of my or left edge of my window. This is my xw maximum. This is also considered as my right side window. Getting me? What is this? This is my yw minimum is also considered as my bottom edge of the window. This is my yw maximum. This may be considered as my top edge of the window. So I'm considering left, right, bottom and top edges of this window, which are defined by xw minimum, xw maximum. Okay, so xw minimum should be my left edge, xw maximum should be my right edge, yw minimum should be my bottom edge and yw maximum should be my top edge. Getting me? So I if whether the edges of the clip window are can be either the word coordinate or maybe window coordinate system. Now the main important question or main important condition is if any of these four equalities, any of these four equalities are not satisfied. Okay, what I want, x value, okay, x must fall in between xw minimum and xw maximum. So value of x should be greater than xw minimum and less than, greater than or equal to xw minimum and less than or equal to xw maximum. So this is my condition number 1, this is my condition number 2. What is condition number 1? Value of x should be greater than xw minimum. Value of x should be less than xw maximum. Similarly for y, this is my condition number 3. The value of y should be greater than yw minimum, greater than or equal to yw minimum. And this is my fourth condition here. Okay, my yw maximum, a y value should be less than y or equal to yw maximum. So if any of these four inequalities not satisfied, okay, then what we are going to do, then the point is clipped. Okay, any of the condition false, okay, not satisfied, then the point is clipped because the point is outside and is not saved for the display. The point is not displayed. If all the conditions are satisfied, means my x value is between the xw minimum and xw maximum, y value is between yw minimum and yw maximum, then the point is saved for display. Is saved means the point is displayed. Else we can say If any of the four condition falls, any four of the categories are not satisfied, it indicates that the point is clipped and it is not saved for the display purpose. Okay, so this is the simple condition for point clipping. Okay, so the point clipping is very simple. Okay, but it is not used for so many cases, so that is what the point I have mentioned. Point clipping is applied less often than the line clipping and polygon clipping. Maximum application uses the line clipping or polygon clipping, and the point clipping is applied less often. Okay, but some application, there are few applications, there are some applications, okay, may require a point clipping algorithm. There are some applications where you have to activate the point, or where you have to display the point or distribute the point, depending upon whether the point is inside the clipping window or whether the point is outside the clipping window, but its applications are less as compared to line clipping and polygon clipping. Okay, as compared to this, it is having, point clipping is having less application, but it is very simple. Just I have to put all these four conditions. I have to check whether the point is inside or whether it is point is outside the clipping window. Okay, so with this discussion of the point clipping, okay, we are moving to the next slide or next stage, where we are going to learn the concept of line clipping now. Okay, so now I am not going into the detailed algorithm of the line clipping, but let us understand the basic concept of the line clipping. Okay, so I'm just moving to the next slide to understand line clipping, what is mean by the line clipping. Okay, so let us start understanding. So what is the point of discussion now? The point of discussion is line clipping. We are going to learn the line clipping concept. Okay, a line clipping procedure involves following parts. Okay, so whenever I go for line clipping, it involves following part. Okay, so which are this part? The first one, see, whenever I go for clipping a line, I have to decide, okay, I have to decide the visibility of the line. I'm using this word. I decide visibility of the line. Find out the visibility of the line. Okay, so what is the first test? We can test. What is the first condition or test is we can test where if a given line segment to determine whether it lies completely inside the clipping window. What is my first visibility test? My first visibility test is if the line segment that I want to determine, I want to go for the clipping, whether it lies completely inside the clipping window, means it's both the endpoints are inside. Okay, then I call that line is totally visible. Okay, totally visible means the line is totally inside my, the line is totally inside my clipping window. Okay, so second option, second test is if not, suppose the line is not totally inside, okay, totally visible, line is not totally inside or not, line is not totally visible, what I need to do, I will go for the second test. If it does not, means if it is not satisfying the condition number one or test number one, then I will check, we try to determine whether it is lies completely outside. In case number one, I check whether it is completely inside. If not, I will check whether the line is completely outside the window. Generally, I call it as totally invisible. Okay, I call it as totally invisible. Okay, so if it is totally visible, no. Then I will check whether it is totally invisible. No. If it is not totally visible or it is not totally invisible, then obviously it indicates that this is my step number or test number 3 indicate that finally if it is not totally visible and it is not totally invisible, okay, not totally visible, not totally invisible, then I consider the line is partial. Okay, so what is mean by partial line? The meaning of partial line is some part of the line is inside the clipping window and some part of the line is outside the my clipping window. Okay, so that is what the procedure, the clipping algorithm, the line clipping procedure or line clipping algorithm involves the following three parts, or I call it as this is my visibility test. Okay, So I first find out whether the line is, I repeat again, the line is totally invisible, totally visible, means it is completely inside. Then I check whether the line is totally invisible, completely outside, or whether the line is partial. Okay. So next thing that I'm considering, now if the line is totally visible, then what it indicates, the line will be saved. If it is totally invisible, it is not saved. But if it is partial, if the line is partial, what we have to do, we must perform or we must calculate the intersection point of the line with the window edge. Okay, that we have to find out. Okay, I'm just showing you here so that it will be more easy for you to understand. Suppose I considered this is my green color, indicate it is my clipping window. Okay, just look at the diagram what I'm drawing. Assume that this is my clipping window. Okay, this is my rectangular clipping window. Okay, I just change the color here, and now suppose I'm just showing you this is my line. Okay, this is my line generally having the points, or I consider it having the two end points, point number 1 P1 and P2. So my line is having two end points, P1 and P2. Getting me? Now here, whether the line is totally visible, no, it is not totally visible. When it is totally visible, if the both endpoints are inside. Okay, if my line is, okay, something like this line is now considered as an example of totally visible line. Okay, now what about P1 and P2? Line P1, P2, it is not totally visible. Whether it is totally invisible, no, it is not totally invisible. Now I just consider another example. Suppose this is my line. Okay, now what about this line? This line is totally invisible because it is completely outside my clipping window or outside this rectangle. Okay, so what about line P1 and P2? The line P1 and P2 is partial. Okay, my line P1 and P2 is partial. So what we have to do, if the line is partial, we must calculate the intersection point of the line with window edge. So this is my line, it is having the intersection with this. Now I think I can easily show you what is my left edge of the window. Obviously this is my left edge of the window, this is my right edge of the window, this is my bottom edge of the window, this one is bottom edge, and this is my top edge of the window. Okay, so now this is my left edge of the window. Okay, for left edge, what I have to find out, I have to find out the intersection point. This point I have to find out. The P1 and P2 is my line. I have to find out the intersection of this P1 P2 to my window edge. Okay, this point I have to find out. Okay, that is what we have written. We must perform or calculate the intersection point of the line with the window edge. Okay, we process line with inside outside test by checking the endpoints of the line. Okay, by checking the endpoints of the line, we are going to consider check the endpoints of the line. Okay, so now I have must move to the example now. Okay, I've just now we have seen the details. Now I'm just considering the example on this particular slide. Okay, so consider the example of the line clipping algorithm. Okay, so this is my diagram number A before clipping. Okay, before clipping. Now I'm considering this, suppose I'm just numbering these lines. Okay, I just change the color here over here. Okay, I just numbering the line. Suppose this is my line number 1. Okay, this is my line number 2, because all the lines are having, yes, P3, P4, P1, P2, but I just mentioned the numbering for our understanding. Suppose this is my line number 3, this is my line number 4, and this is my line number 5. Okay, so I just numbered this line, and this is my clipping window. Okay, this is my clipping window. Okay, now what this example shows, what this diagram shows, the line clipping against a rectangular clipping window. So this is my window. Now you can, it is easy for you. Okay, why it is easy for us or easy for you is because we have to find out we apply the visibility test. Okay, suppose my line number 1. So what is my line number 1? P3, P4, this is my line number 1. Getting me? This is my line number 1. What happened to this line? As per our test, this line number P1, P2, okay, this line number P1, P2 is totally invisible. Okay, totally invisible. So whether it will come in the after clipping diagram number B, it is not displayed here. Okay, so I consider I just divide this into two parts. Okay, so this is before and this is after. So whether that P1, this line number 1, P3, P4 as displayed here, no, because it is totally invisible. Come to the line number 2 now. Okay, what is my line number 2? Line number 2 is totally visible. Okay, if it is totally visible, I have to draw the line. Getting me? What about line number 3? Just look at the line number 3. This is my line number 3. Now this is not totally invisible, totally visible, but it is partial. Because why it is partial? Some part, I can just showing over here, some part of the line is outside and this part we have to clip. So you can find out, this is my line where this intersection point I am finding out, and the outside part is removed. Okay, there is very small part which is outside, this particular part is removed now. Okay, now what about the P4 line, sorry, fourth line, line number 4? You can find this line is also partial. Okay, but it is now intersecting two edges. Okay, this is one of the intersection point and this is another intersection point. So this part will be discarded, this part is also discarded, and only this part is reserved or it is preserved for the display. Okay, so this is what the example. I hope all of you easily understood with this example what is mean by the line clipping and whatever the three tests we have performed. Okay, and accordingly we are going to do it. What about the P5 line? I think I have also we are having one more line here, that is the fifth line. This is my fifth line. Okay, so you can find this is my fifth line. Okay, now what happens with this line number 5? Obviously this is my window and this line is totally outside. Getting me? This line is totally invisible, this line is totally outside. So we have drawn this over here, no, so it is simply discarded. Okay, we have not shown this line number 5. Okay, so here I can say the line number 2 is totally visible, that is displayed inside the window. Line number 3 and 4 are partial. We are going to find out intersection point. Outside part of the line is discarded. The same thing happens with the line number 4. The part which is outside this window is discarded. Okay, and we are getting this diagram after clipping. So this is what we have to achieve. Okay, this is what we want to do. Okay, under the line clipping. Okay, so definitely we are going to see the different algorithms which are used. See, I'm just explaining this conceptually. Okay, but we require some algorithm, some steps to which is going to perform, which is going to convert. If this is given as the input, suppose I give this as the input, what is my expected output is this. Okay, line clipping algorithm should give me this as output. Okay, and for that we required some algorithm. Okay, that we are going to learn into the next session or the next lecture. But before that, whatever the conclusion that we are having, what action we are going to take for the totally visible line, what action we are going to take for totally invisible line, and what action we are going to take for the partial line. Okay, that I have shown on the next slide. Okay, that is our concluding slide, that we have shown what action we have to perform. Okay, so in this slide, okay, what I have taken, I have considered as the three cases. Okay, just now we said what action we are going to take. So case number 1, a line with both endpoints inside. Okay, the line is having both the endpoints inside the clipping boundaries or inside the clipping window. That is, the line is totally visible. And if the line is totally visible, what we have to go? We are going to save the line and display the line. Okay, so this is my action. What is the action we have to take for totally visible line? We have to, for totally visible line, we have to save it and display that particular line. Case number 2. Okay, a line with both endpoints are outside the clipping boundaries or outside the clipping windows. That is, my line is totally invisible. The line is totally invisible. What action I am going to take? I am going to take the action that this line is removed or not displayed. So this is my action. Okay, removed or not displayed. So what, obviously my case number 3 is for partial line. Case number 3 is for which line? It is for the partial line. Okay, so case number 3 is all other lines. Okay, means which are not satisfy the condition of case number 1 and case number 2. The line is not totally visible, the line is not totally invisible, means the line is partial. Okay, so all other lines which are partial, okay, if line is partial, we have already seen this in our previous example or the diagram. What we have to calculate the intersection point. We have to calculate the intersection point of the line with window edges. Okay, calculate the intersection point of the line with window edges, find out the intersection point, and clip the outside part of the line, clip the part of the line which is outside, and preserve or display the part of the line which is inside the clipping window. So for the partial line, first calculate the intersection. What is action? The action we are going to take is calculate the intersection point, and once we get this intersection point, we can find out the part of the line which is outside. Okay, it should be removed, and the part which is inside, it should be displayed. Okay, which is inside, the part which is inside the clipping window should be preserved or displayed, and the part which is outside should be removed. Okay, or it is not displayed on the screen. So we have to do all these actions for the line clipping algorithm. Okay, now the which method I am going to use, which method is applicable to do all these things. So what is the algorithm to find out totally visible line? What is the condition for finding totally visible line? What is the condition to find out the line is totally invisible? What is the condition to find out the line is partial? How we can calculate the intersection point? How I am going to remove the outside part? How I am going to preserve the inside part? All these things will be learned in the next session with the help of algorithm. So next session we are going to learn the Cohen-Sutherland or Sutherland line clipping algorithm. Okay, so different methods are there, and we are having different algorithm which are called as the line clipping algorithm. So in this session, okay, we have learned the concept of what is mean by clipping. Okay, what is clipping, how it is defined, then we have learned what is mean by the point clipping, and then just now we have learned what is mean by the line clipping, or how I can achieve the line clipping algorithm. Okay, so this is all about for our today's session. Okay, so next section we continue session we are going to continue with the line clipping algorithm. Okay, thank you all the students.